Hello everyone. Today we are going to go over branching statements, or sometimes called condition statements, and sometimes called flow of control statements. Now all of these together control how our program actually runs. Now usually programs are top down, meaning that execution of the program starts at the beginning of a block, or in this case a method, and goes all the way to the end of it. Now, once you start getting into more advanced topics such as object-oriented programming, that's going to change a little bit because we're going to have things called threads. We're going to have things called, event handlers. It's going to get kind of more complicated than that. But for now, not really. For now, things in our world are still pretty simple, and we're learning the basics about how a computer program operates and how it actually runs. So we're going to continue with that today. Now, specifically, my goal for us for this simple demo that I'm going to be running is going to be to understand the concepts of a simple if statement. If as in as if, right? So an if statement, what it does is in a program is it evaluates what's called an expression, and it continues control based on the outcome of that expression. Now, what does that mean in English? Well, we're going to start with a simple if statement, and we're going to get a little bit more complex as we go. And for the sake of brevity, meaning we're not going to keep it hard, I'm going to keep things as simple as possible, just so we could get into this proverbial swing of things. And also remember that I'm not going to be using anything such as methods or functions. I'm just going to quite simply just demo if statements. So let's do the following. We have the famous Hello World program here. I'm going to modify it for a simple if statement. We're going to put in two variables. I'm going to put in int, and I'm going to put in age. How about this? My age. By the way, later on in your programming career, you're going to learn some better ways of naming your variables. Right now, I'm using just simple names right now. Eventually, there are different conventions that you can use to name these things. In case you had any questions. For now, I'm just going to call it my age, and I'm going to say I am. Actually, no, put in my age. Let me do my assignment. I'll say pardon me. Let me go back there. Let me change or add my assignment. So I'll put in my age is equal to, and I am 39 years old. And I'll use an integer. You should know the difference by now with the numeric data types. So I'm going to skip over completely floats versus doubles versus integers versus longs. So right now we're only going to be working with integers, which is simple, and we're going to be working with whole numbers. So I'm going to put out, how about this? System.out.println you are, and I'm going to concatenate the age. I'll put in 39 and concatenate. That's what the plus means. It means concatenate. You know what that means. Just add it on. Years old. Okay, simple program. I don't have an if statement in here yet. Don't panic. Bob said he was going to put in an if statement. He didn't put one in yet. Nope, I did not. So let's just execute my program, make sure it runs. And we should get something out here that says I am 39 years old. There we go. Another concept I'm going to kind of emphasize along the way here. Notice, since this is a beginning coding class, notice when I write my program, I start with very simple lines of code and I run it as I go. That's a very common and industry acceptable technique. Don't write 1,000 lines of code and try to run it. Only do it a few lines at a time. So That way, when your program doesn't run, you could go back and you could fix it, right? You don't got to figure out why it doesn't work. And certainly I see that with a lot of your work too, especially when you're a beginner, is you tend to write it, some of you tend to write it like a book report. You put some code in, you put some code in, you put some code in, put some code in, just like you would if you were writing an English paper, right? And then when you're done, you proofread it and make your edits. Now, when you write software, it doesn't work like that. Picture this. Picture writing like a paper in English and proofreading it like every sentence or two. That's exactly how you write code for a successful technique. I always say, in English slang, if you don't know what this means, you don't have to. I'm a big baseball fan. I love the Chicago Cubs. My wife and I live right by Wrigley Field. So I always say, don't go for the home run. Don't go for everything when you're writing code. Get simple things to work and then go back and add things as you go. All right. So soapbox over. You are 39 years old. So let's put an if statement in here. I am going to say, how about this? First if statement. I will say if, put a line here just for readability. Open paren, and I'll say my age is greater than 39 I'm going to put this on top. And again, you can follow along with me if you want. You can just watch. You can pause the video, do whatever you like. So how about this? If my age is greater than 39, I will say, how about this? Just to show you what's going on. Man, you're old. And end my if statement. Now, a couple things about this. Notice in Java, we deal with these open braces and closed braces. Remember, they're called blocks. Now, as a review, remember this is called our class block, right? So this one ends here. And also, notice with your compiler, if I highlight this brace, you can't really see it, but you should see kind of this one highlight here. This is my main block, which is my main method. And then I have my if block. So every time you start, in most cases, when you start with a brace, you end with a brace. And also, you might not be able to see this in the video. You see a nice alignment here, which is perfect. Remember, you want your code to look pretty for reasons other than narcissism. You want other people to look at your code and know what you're doing. That's why it's important it's indented in a certain way. Now, as you probably know by now, indenting your code and making it look good isn't necessarily a requirement, meaning syntax. You don't have to do it, but you should do it. And as a matter of fact, when you work professionally as a software engineer or a coder, you will get dinged on that in code reviews and peer reviews about indenting and making sure your code is readable. So technically, I could put this all on one line. This could all be on line 1 if I wanted to, but don't do that. Don't. Keep your code nice and readable. Okay, soapbox done. Let's get back to the if statement. So here's a simple if statement. Now your if, again, just to go over some vocabulary, it's called a few things, and don't ding me on my definitions because I'm fully aware that some of these definitions vary slightly. So work with me on this. This is called a flow of control statement. Now with a flow of control, slow down, Bob. A flow of control statement is a block of code, which this is, that branches the execution. What does that mean in English? That means that in this if statement, this expression, right? The expression starts in a open paren and a closed paren. This expression evaluates true or a false. So, my age is greater than 39. Is that true or is that false? In this case, it would actually, well, it'd be a tricky one. How about this? Let's change this. How about to make it simple? Just to express my point. If my age is greater than 20, do this block of code. And I'm speaking in plain speak English. I'm not speaking in computerese. Again, if my age is greater than 20, so if this is true, do this. Otherwise, don't do this. That's why a lot of times this is called the flow of control, because this if statement changes the control or where the code is executing, or which code is executing in your program. And this is a simple if. Again, this is called a conditional, again, because this is a condition, again, or an expression, and it changes the flow of control. So now if I run this, I should get what? You are 39 years old. Man, you are old. Because guess what? 39 is greater than 20. All right. Pounding this into the ground too much for you guys. You guys are too smart. Okay, so let me click on execute. And then you go, man, you are old. Now, also what I can do is this if statement is fairly complex. Now, I'm going to leave it to you. It sounds like I'm summing things up. I still got a bit more here. Sounds like I'm summing things up. Let me explain to you my approach. If statements are fairly complex. As you can see, they're easy to understand, but the syntax can get more complex. You could have nested ifs. You can have more than one if. You can have an if within an if. But guess what? My style is to show you the basics and show you what you need to know to take it a little bit further. I call it the grocery shopping approach. And for those that know me, know what I'm talking about. This is how I approach this. If you know nothing about grocery shopping and I meet you at the entrance of a Jewel or a Treasure Island or a Pickwick or a Safeway, depending on where you live, and you say, hey, Bob, I've never went grocery shopping before. Can you show me how to grocery shop? Okay. Now, there's two different ways that I can do that. Well, there's more than two, but there's two different approaches. The first approach is I could bring you to every item in every aisle and say, this is where you find the shampoo. Here's where you find the dandruff shampoo. Here's where you find the conditioner. Here's where you find the after shampoo dry conditioner. And after a while, you say, wait a second, these are kind of all the same thing, aren't they? And then I would say, yes, they are. And then you would say, well, the same things are really in the same aisle. I just need to know where the hair care products are. And that would be correct. So that would be one approach for me to showing you how to shop. Another approach would be what you just mentioned in my imaginary scenario, where you could say, you know what, just show me the aisles. Show me where I can find the hair care. Show me where I can find the produce. Find me where I can find household. Show me where I can find the baked goods, meat if you eat meat. And then I can take it from there. Now, the latter approach is how you want to learn programming. You don't, in my opinion, you don't need someone to show you every syntax of every statement. Because once you get the recipe and you get the roadmap of how it works, where to go for help, basically how to construct an if statement, you can figure out the rest. Just like if I showed you how to shop and you came to me and you said, I want to know where the bread is. I would say, go to baked goods. You'd go to baked goods, you'd find it. And where you'd say, Bob, I need to know where light bulbs are. And I would say, go to the household aisle. I don't need to tell you, take 10 steps to the left, go 5 steps straight. I don't need to do that. I say, find the household aisle. You will find the light bulbs there. That is how, again, you learn how to write software. Get the big picture, know generally what you're trying to do, get in the right area, and then figure it out. If statements work just like that, and that's the last time I'm going to give you that analogy. So do your reading. It sounds like I'm wrapping things up, but I'm not. If you need more syntax and if statements, Google is your friend. Google Java if statements, and then you'll get all of the syntax. You'll get more code examples I can show you in my lifetime. So it doesn't make sense for me to show you things that already are out there. I'm just teaching you how to get the darn thing working. All right, now was one more thing with that. If statements, as we're talking about them, exist in any software language. This is not just a Java thing. You're going to need to know how this works in any language you're going to be using. Pick a language. It uses flow of control. It uses if statements, expressions. All that terminology is valid everywhere in writing code. So don't worry about just learning this for Java. It's going to be used everywhere. All right, so you got that. So let's just make this a little bit more complicated. Just when I told you I wasn't going to show you, more stuff, I kind of am. Let me show you an else. And again, I am going to show you a couple examples, but not like all 165 gabillion. We also have an else. Now, an else is if this is not true, right? Right now we have if this is true, do this. Otherwise, don't do it. We can add to this and say if this is true, do this. Wait for it. Otherwise, do something else. That's called an else. So an else is its own block. So after the if, which ends here, right? This is the beginning of my if statement. This is the end of my if statement. I can also add an else block. You know what blocks are, right? Blocks start with what? How about this? I'll just put one in. Put an else. I've had too much coffee this morning, and sometimes when I have too much coffee and I drink coffee all day, I have a hard time getting to the point. So let's go else. You're like, we know, Bob. And also take a look how Java's nice enough. Notice how I didn't type this. Java put it in for me. So we got our if block is here. Our else block is here. So the else block is if this is not true. Remember, if this is true, do this. Otherwise, do this. And I'm going to put in, how about this? Something simple. We'll put in, man, you are young, right? Either you're old or you're young. Right? 39. Hey, it can happen. I used to use that 39 all the time, and no one used to laugh. Now I use it, and they're like, yeah, Bob. Right, we believe that. But it could happen, right? So anyway, I'm going to pause for a second, and fully realizing that you're watching this on a video, and you could pause it anyway. But old ways die hard. So at this point, I'm going to execute my program. And I get you are old, right? Because 39 is greater than 20. But if my age was 18 and I execute the program, I should expect to see, man, you are young. There you go. Man, you are young. What you are looking at right now on line 8, 9, 10, and 11, and 12 is a simple if-else block. Now, that terminology is used everywhere. If you're writing it in C#, Visual Basic, Power Builder, Python, they're called blocks. This is an if-else block. This is an extremely simple flow of control statement, right? Because what it does is if, look at line 8, if this evaluates to a true, line 9 is executed. If line 8 evaluates to a false, line 11 is executed. It goes to 11 because it's more than 10. Did you ever see that movie, Spinal Tap? I'm going to give you guys an extra credit point sometime in the semester for watching that movie. Anyway, back in the days when, you used to watch really good movies on cable and you used to go to the video store to get them, If you're under the age of 25 years old, you're scratching your head because you don't know what a video store is. You're like, wait, isn't there a Redbox in Walmart? Well, there used to be video stores too. Google it. Google Blockbuster Video if you want to feel really young. Not only did you guys miss 8 tracks, you missed 8 tracks, cassettes, albums, CDs, DVDs, laser discs, and everything. Now everything's electronic. It's boring. I mean, now we all go online and we steal music. Back in my day, we had to go to a record store and shoplift that album ourselves. And that was hard to do because an album, it was really big and it's bulky. And if you ever tried to put it in your shirt, the clerk would know that you're stealing it. So it was a lot harder to steal music and video back then because you actually had to go in there and shoplift it the hard way. So you guys got it way too easy. All right, anyway, that is a simple flow of control statement. Again, also called a conditional. So let's make this a little bit more complex. Okay, before I do that, I want to point out something because the 18 is hard-coded here, just to illustrate how my if statement works. Now remember, this 18 can be passed into my program. You should know by now how to pass in an argument or how to pass in something to a Java program. If you don't remember, you can look it up. You don't need to know it in the next, 15 minutes. But just remember that we don't have to hard code our values. These values can be formulas as well. I mean, these formulas can be passed in from somewhere else. So what I'm going to do is in the last example, in the last 10 minutes or so of this demo, is I'm going to kind of keep this the way it is, the if statement and the else. I'm not going to change this. But what I am going to do is I'm going to kind of make 18 into a formula so we can do something a little bit more realistic. How about we do the following? I'm going to kind of make a change here. I'm going to call this one, rather than my age, I'm going to call this one my salary. And how about this? We're going to make a fictitious scenario here. We've been asked by HR to write a program that looks at an individual salary for an employee. How about this? I'll put in, rather than my salary, I'll put in my total salary. And how about this? And we're making this up as we go because we can. This is our class and we can do whatever we want, right? All right, so my total salary is the total dollar compensation. And it is the hourly rate that you make. Let's just say you make $16 an hour or $70 an hour, doesn't matter, times the hours that we work, right? And then we'll also say times 1.15. Let's just say that as far as our employer is concerned, there's like a 15% overhead on what they give us. Let's just say that's like a benefits. Like, for example, if you and I had a company and Johnny worked for our company, we had Johnny worked for our company, and Johnny made $10 an hour and worked 40 hours a week. As an employer, we could say, well, Johnny makes more than $400 a week, right? Johnny says I make $400 a week, right? Because I make $10 an hour times 40 hours. I make $400 a week. But us, as Johnny's employer, might say, well, you really make $500 a week if you factor in that we have to pay, unemployment security. We have to, if you're lucky, maybe Johnny gets benefits. So there's more of a cost to us. So let's just say you and I, we ask our software developers to calculate that. Say, what we want you to do is we want you to calculate the true cost of what an employee costs us based on a formula. And what is that formula? Well, we just made it up, right? So how about this? Total salary. So we'll say, and how about this? We're going to get rid of this. We're going to start from scratch. So we'll say, how about this? My total salary, and we're going to put an int, and we're going to put in my hours worked. We're going to put an int. We're going to put in my rate, right? These are variables. We can name them anything. On purpose, I'm going to put in a couple mistakes here. I want us to debug these as a class. I'll give you a second. Some of you are typing this in, so I'm going to give you about 30 seconds of dead air to maybe pause the video if you're catching up. If not, if you hear 30 seconds of dead air, it's just because I'm giving you a sanity break. So pause the video if you like. Otherwise, we'll get started in about 30 seconds. All right, let's continue. So we'll say, how about this? We'll say my hours worked equals 40.5. We'll say my rate is equal to, I make $15.67 an hour. And how about this? The formula would be, how about this? My total salary, I on purposely, I could feel your energy through my microphone here because I am purposely put a couple things we need to debug in here. So if you see them, just be patient. We'll get right to them. My total salary equals, how about this? We'll say my hours worked times my rate and we'll multiply that by 1.15. Why 1.15? That's the number that they gave us. Let's just say that HR says that each employee has 15% overhead. So that's our formula. Now, a little bit about formulas. Now, we probably should have a little more on this a little bit later, but notice how we have not really an expression, A plus B or A divided by B, but we have more of a complex formula, which is not only allowed in programming, but encouraged or used all the time. Now, for formulas to work, you need to remember your high school algebra. Remember you had in algebra, you had the order of operations. Remember in algebra, you had like quadratic equations and what was executed first, right? Algebraic expressions, slow down. What you're seeing here is this formula is an algebraic expression. It's algebra. So for those of you that have to remember your high school algebra class, I dread that you have to. Otherwise, I guess I can teach you one if I can even remember algebra. Who remembers algebra? Nobody, right? But anyway, it's important in software because formulas follow perfectly your algebraic order of expressions, which is great because that means no matter which numbering system you use, you know algebra. Algebra does not necessarily use base 10 math. So whatever currency or numbering system you're used to, expressions work the same way. All right, so anyway, before I put an if statement in here, remember I said you got to execute this often? I'm going to do that. So I'm going to click on execute. I'm going to get an error. Look at this. Incompatible types. Lossy. Lossy sounds like a rap band, doesn't it? Right? It'd be like my rap name. Actually, my rap name is either Puffy Sleeves or Ice Cube Tray. You guys get to pick that one. So what do you think for my hip-hop name? My daughter likes Puffy Sleeves, but I like Ice Cube Tray. So anyway, lossy. This is what lossy means. Lossy just means that there's going to be, how does this, let me start at the beginning. Lossy means approximation. in software. Lossy means we're going to have to approximate what you mean. Lossy is not good. Lossy means I don't know specifically what you're trying to do, so I'm going to think about what you want to do and try to do what you just asked. That's loss. So like, if, for example, if I asked you to run to the store for me, and I would say, I want you to run to the store, and it's 4 o'clock in the morning, that would be a lossy expression, because you would say, which store do you want me to run to? What do you want me to get? And do you understand it's 4 o'clock in the morning? That would be a lossy expression. Now, that's not a lossy math expression, but that still approximates or illustrates what loss means. Lossy means I don't know what you're trying to do, so in this case, I'm not doing anything. Now, lossy in this case means that we have a problem with our data types. We're using integers. Integers are whole numbers. Remember, whole numbers, no decimal. I'm 39 years old. I'm not 39 and a half years old. 39 is a whole number. 39 and a half is not. My hours worked. Raise your hand. Is this a whole number? No. Whole numbers. I'm saying it's a whole number here, right? Hours worked. And then here I'm saying it's not a whole number. Java's saying, no, homie, you don't like that. Okay, you pick one. It's either whole or not. Same thing with rate. I'm getting that error. So what I need to do is I need to determine if these are whole numbers or not. And I'm guessing they're not. So we're going to change the data type. Rather than int, we're going to use what are called floats. So we'll say, how about this? Yeah, well, hold on. I'm ahead of myself. But float. Float means floating point. That means a floating decimal point. Floats, not like the floaties you put, on your kid's arm when you're at the Franklin Park pool. But float just means that there's a decimal point in this number, and it floats to different numbers of precision. So it could float, and it could handle just tenths. It can float over one position to the left, and it can handle hundredths. It can float one more position to the left and handle 1,000ths, and so on and so forth. So float means floating decimal point. So we'll do the same thing for my hours worked. We'll do the same thing for my rate. And remember, I said align. Make it look pretty. Remember, you're an engineer. Software engineering is a skill, and it's a discipline. You make things look nice. It's an engineering skill just like civil engineering, electrical engineering, chemical engineering. If you're a civil engineer, you don't want your bridge looking like crap. Even though it might work fine, you make it look nice. Same thing with your code. It shows pride of ownership. Now, also for hours worked, since it's a float, we have to put an F here, and we put an F here. Remember, F just means float. What we're doing here is we're telling Java what this is. Java already knows that 40.5 is not an integer. It already knows it's not a long, but there's a decimal. So it doesn't know if there's other decimal types, just so you know. There's others other than float. I'm not telling you what they are just to keep it simple. You can look them up. Remember, grocery store approach. Look up other decimal types. They do exist. You know which aisle to look. Go. Speak amongst yourselves. Okay, and my rate as well. So 40 and a half hours, my rate, total salary. This is evaluated first. We take the product of these two and multiply it by this. And let's make this clean. Notice we still don't have an if statement. We're getting there, right? You're like, we're talking about if statements, and we are, but I'm just trying to give you a little bit more here. So I execute, and I still got a lossy conversion. You know why? I'll give you a second. Debug this for me. Line 10 has a lossy conversion. I'll just tell you what it is. My total salary is a float. This is a float. My hours worked is a float. My rate is a float. What data type is this? Java says I'm not sure. I think it's a float, but it could be a decimal. It could be a lot of things. Bob, what is this? Help me. And I'm like, it's a float. So I do this. and I get a clean compile. It doesn't show me anything yet, but I didn't ask it to. I'm just trying to get it to compile. But look at the methodology I'm using, kids, ladies and gentlemen of the jury, Your Honor. Speaking of, long story. Yeah, I'm broadcasting from prison right now. Anyway, notice how I'm building this. I only wrote 6 lines of code, right? But I'm kind of debugging it as I'm going. I'm not going to write 70 lines and have it not work. But how about this? Now I throw in my if statement. I'll say if. How about this? If, put in my expression. How about this? My total salary is greater than, and again, I'm making these numbers up. In reality, we'd have to get these numbers from HR, whoever's designing this program for us. We would say, they would give us this number. And how about this? If it's greater than, we'll put in like, I don't know, $1,000. We have a secret here. How about this? If our salary is greater than $1,000, what we do is that we make it our max salary. We'll say something like total salary equals $1,000. And we'll say else. How about this? If it's less than $1,000, we can say something like my total salary is equal to, how about this? If it's less than $1,000, we just add $100 to it. Again, don't get too stuck in what we're doing. You have to use your imagination a little bit as far as the scenario goes. So I'll say equals my total salary, and we'll put in plus $100. And I need my else block. Notice when I put that in, well, Java didn't put it there because I didn't do it from scratch. And we'll say system.out.println, and we'll put in real salary is equal to my total salary. So what I'm doing here is I'm giving you a formula and just evaluating that formula. Don't get too hung up on what we call the business logic here. You're like, why is it 1,000? And then if it's not greater than 1,000, why we add 100 to it? That's just our scenario that we're running. In English, it would be like this. We're writing a program. Our program computes the total out the door salary for our employer. Not what we pay the employee, but, out the door. So what we do is we look at how many hours Johnny worked. We multiply it by Johnny's hourly rate, and we multiply the product of that times 1.15, or it's like adding 15% overhead. 15% overhead is unemployment insurance, office expenses, health insurance. We give them free meals if they're a server. So that's the total expense, the total salary that we can expect. Then we just have some logic here. And again, we're saying, well, if the salary is greater than 1,000, just make it 1,000. We don't want it to go over for some reason. Just for whatever reason, we don't want this number to go over 1,000. And if it's not greater than 1,000, if it's less than 1,000, we're just going to add $100 to it. And I fully realize if the salary is like 900 and then we add $100 to it, it's going to be over 1,000. But just work with it. We have to kind of use our thinking cap and kind of excuse some small little moment lapses there. But just to illustrate the branching, that's all I'm doing here is I'm illustrating branching. If this is true, If line 12 is true, line 13 gets executed. If line 12 is not true, false, right? Line 15 is executed. This is branching. This is a simple, I'm wrapping this up, wake up. This is a simple branching statement. This is a flow of control because we're changing where, or we're not changing. We're determining which code gets executed or which flow gets executed. It's branching because it either branches to here or branches here. And it's also a conditional. And again, don't get too stuck on those definitions. I won't ask you what they mean. No one's going to. No one's going to ask you the difference between a branching and a conditional and an if statement. No one's going to ask that. They will ask you things like, maybe, like what we did here, the difference between like a float and an integer. That's something kind of important. But what I'm talking about here are just rough terms that we use to describe, in this case, else if statements. Now, there's other ones as well. You've seen an if, right? And you've seen an if else. Now it gets more complicated than this. Google is your friend. You need to know more about ifs and elses. Look them up. In this case, Google, Java if statement. WC3 schools, and other sites have more code examples I can show you in my lifetime. So go there because I don't add anything to that, so I'm not going to waste your time. There are other flow of control statements that we haven't talked about here. Maybe we'll talk about them later, such as while statements. Not covered here, don't panic. For next loops. Didn't cover them here, don't panic, but they're coming. So there are other conditionals, other flow of control, and other expressions. You just saw one of them. All right, this is all I had for you today. So thank you for your time. Thank you for paying attention and staying awake this long, if you're still awake. And I bid you all a very well rest of the day. Thank you.